Today we'll discuss analysis of member with the translation of joints by Kani's method. This is one member AB. So here you see this is the figure and this member AB, and both hands are restrained. And due to this restraint, and this is the lateral displacement of the end of the member. So here the member end A you are displaced to this position A dash, and B you are displaced to this position B dash. So this is the displacement at A, and this is the displacement at B, delta B. And the relative displacement of end A and B is your delta, because this is your delta B and this end is your delta A. So the difference between this delta B and delta A is equal to delta. Delta is equal to delta B minus delta A. And this is the moment, the M double dash AB, and here the moment M double dash BA. The above figure shows a member AB in a frame which has undergone lateral displacement at A and B, so that the relative displacement delta is equal to delta B minus delta A. It may be noted that the ends are restrained from rotation. The ends are restrained from rotation means both ends are fixed. And this is the lateral displacement, and this is the relative displacement between A and B. And this is the moment M double dash AB. Due to this relative displacement, this is the moment induced to M double dash AB, and this is your M double dash BA. The fixed end moments corresponding to this displacement are M double dash AB is equal to M double dash BA is equal to minus 68 delta by L square. You know, due to the lateral displacement, this is the fixed end moments. So already we have discussed in slope deflection, in all method moment distribution, and also you know in fixed beam. So when there is the settlement of the support takes place, and what is the moment at the end of the what is the fixed end moment at the joint? M double AB is equal to M double dash BA is equal to minus 68 delta by L square. So in this case, due to this the relative displacement delta, so what is the moment this side and this side? So this is equal to minus 68 delta by L square. This is the friction moment due to the lateral displacement of the joint. When the translation of joints occur along with rotation, translation of the joint takes place. When the rotational displacement takes place, then what is the moment at the end of the member? You know, or when the translation of joints occur along with rotation. So what is the two end moments? You know, this is your MAB is equal to MFAB, and 2M dash AB plus M dash BA plus M double dash AB. So this is the piston moment due to the external loading, and this is the near end rotational moment, and this is the far end rotational moment, and this is the translation moment. This moment is your translation moment. This is due to the lateral displacement. This is due to the lateral displacement of the end of the members. So this is the translation moments. So here the final moment when both the translation of joints and the rotation of joints takes place. So that case the true moment that you can find out MAB is equal to this is MFAB plus 2M dash AB plus M dash BA plus M double dash AB, and MBA is equal to MFBA plus 2M dash BA plus M dash AB plus M double dash BA. So this is the formula. So M double dash AB and M double dash BA is equal to displacement moment, or also called translation moment of member AB. This is your displacement moment or translation moment of member AB. So, let us take this frame. So here this is the joint A, and these are the members: AB member, AC member, AD member, and AE member. And all members are made at the joint A. BA, CA, DA, and EA. If A is the joint where two or more members meet, then for the condition of equilibrium of joint A, so the summation of MAB is equal to 0. That means MAB, MAC plus MAD plus MAE is equal to 0. That you can indicate summation of MAB is equal to 0. Then we will apply this equation to all the members. This is for the member AB, this is your for member AB, but at the joint A, 4 members meet, Then we'll apply this equation to all the members, AB member, AC member, AD member, and AE member. Because at joint A, the summation of MAB is equal to 0. So the summation of MFAB is 0 plus 2 into summation of M dash AB is 0 plus summation of M dash BA is 0 plus summation of M double dash AB is equal to 0. Summation of MFAB plus 2 into summation of M dash AB plus summation of M dash BA plus summation of M double dash AB is equal to 0. So this is, if this is your 0, means this is also equal to 0. Then, so you have to find out what is the near end rotation moment. Summation, what is summation of M dash AB? Find out this value, summation of M dash AB. The summation of M dash AB is equal to minus half. So when we'll take, this is opposite side, summation of MFAB, and this is summation of M dash BA, and summation of M double dash BA, and this is when we'll take this side, so minus half. Summation of M dash AB is equal to minus half, summation of MFAB plus summation of M dash BA plus summation of M double dash AB. So we know M dash AB is equal to KB by summation of KB into summation of M dash AB. Already we know in previous analysis. Then here you put what you got here. So this value you put here. You put the value of summation of M dash AB in this equation. So after putting this one, so you'll get M dash AB is equal to KB by summation of KB into minus half summation of MFAB plus summation of M dash BA plus summation of M dash AB. Then just you take M dash AB is equal to minus half KB by summation of KB into MF summation of MFAB, means what is the fixed end moment at the joint A, because summation of MFAB means fixed end moment of this side, this side, this side, and this side. So what is the fixed end moment of joint A is equal to the summation of this four moment. So the summation of MFAB is equal to moment at the fixed end moment at the joint A, MFA, plus summation of M dash BA plus summation of M dash AB. Here you see this minus half KB by summation of KB is equal to the rotation factor. You know this is you know UAB is equal to this one minus half KB by summation of KB, and this is your the fixed end moment at joint A, and this is the far end rotation moment summation of M dash BA, and this is the translation moment, or this is also called the displacement moment. Summation of M dash AB is the displacement moment. So when you want to find out this this one M dash AB, that is the near end rotation moment. So by using this formula, you can find out the near end rotation moment. So that's why you have to know. So what is the rotation factor, and what is the fixed end moment of the joint A, and what is the rotation moment of the far end, and what is the translation moment. But the translation moment that you can find out for the vertical member. Similarly, if you want to find out M dash BA, so this is equal to UBA. This is UBA. This is not AB, UBA. Then MFB plus summation of M dash AB plus summation of M double dash BA. So this is the formula. So using this formula, you can find out what is the rotation moment. Analysis of frame with lateral translation of joints or space. So in the case of frame, if a frame has unsymmetrical geometry or unsymmetrical loading, it will swell laterally, causing relative displacement at the end of the column. At the end of the column, this is your rotate laterally. The lateral sway causes additional moment, which may be called displacement contribution. So this moment is a displacement moment, or this is your translation moment in the case of sway. So that the column is your sway takes place. In the case of sway frame, due to this sway, what is the moment you have to take here? So that moment contribution is your displacement contribution, and that moment is your called the displacement moment or translation moment. So this frame that you can analyze when the height of all columns in a story are the same, and when height of columns in a story are different. When the all story heights are same, so this is the case. So here you see this is the frame having same column height. Here you see in each story, this is one story, this is one story, this is one story, and this is one story. So here you see in each story the column heights are same. Similarly, height of columns in a story are different. When the height of column in a story are different, so that is the different case, the different analysis. So here we will discuss when analysis of frame with a sway when all columns in a story have same height. So this is the frame having same column height and acting vertical loading. So due to vertical loading, so you have to analyze the frame. So let us take any one story. So here we will take this story. So here this story, the height, the 1, 2, 3, 4, 5, 6, 7, 8. These are the vertical members. So let us take one vertical member of this story, 1, 2. Let us take 1, 2. So this is the horizontal force, and this is the moment M12. The moment acting at the support 1 or joint 1 is your M12, and that 2 is your M21. And this is the horizontal force acting at 1 and 2 column in a building frame. So you are considering this 1, 2 vertical member, and at the end of 1 and 2, this is the moment you are acting, and this is the horizontal force you are acting. So you have to find out, consider the frame shown in figure, this one. Such frames are subjected to vertical load, acting vertical loading. Let 1, 2 represent a vertical member. 1, 2 represent a vertical member in any story of a multi-story frame as shown in figure 2. This is M12 and M21 are the end moments at 1 and 2. Already I told you M12 and M21 is the moment acting at the end at 1 and 2. Let the horizontal force exerted by the frame on column be H. This is the horizontal force exerted by the frame on the column. If the height of the story is high, H, this is the height of the story. 1, 2, height is your H. From the equilibrium consideration of 1, 2, what you have to do? So you have to take the summation of moment from 1 is equal to 0. Take the moment about 1 is equal to 0. So here you see when we are taking the moment about 1, so this is the clockwise moment, and this is also clockwise moment, and due to this horizontal force, this is also rotating clockwise. The summation of M1 is equal to 0, that is equal to M12 plus M21 plus capital H into small h is equal to 0. M12 plus M21 plus capital H, the horizontal force, into the distance between them, small h, is equal to 0. Then from this equation, this is equation 1. Then this from this equation, what is the horizontal force? So H is equal to minus M12 plus M21 divided by small h. This is equation 2. So in figure 1, let 1, 2, 3, 4, 5, 6, 7, 8 represent column in a particular story. This is the different column in a particular story. In this story, so these are the column 1, 2 column, 3, 4 column, 5, 6 column, and 7, 8 column. 4 columns. In this story, there are 4 columns. So applying equation 2 to all column of the story. So this is the equation you got. This is horizontal force for 1 column. In this story, there is how many columns? 4 columns. So take the summation of all the column. So summation of H is equal to minus summation of M12 plus summation of M21 divided by H. So you have to take the summation of all columns in that story. So you will get what is the horizontal force from this column, what is the horizontal force from this column, what is from this column, and what is from this column. Summation of horizontal force is equal to summation of M12 plus summation of M21 divided by small h. This summation of H is the shear in all the columns in that story. So you can designate it by QR, Q subscript R. QR is the shear in the earth story. So QR is equal to minus summation of M12 plus summation of M21 divided by H4, HR. So this is your indicate equation 4. So where HR is equal to height of column of the earth story. HR is the height of column. This is earth story. earth story, and the summation of M1 is the sum of the end moments of the upper end of the all column in that earth story. Summation of M12 is the upper end moment, sum of upper end moment of all the columns of the earth story, and M21 is equal to sum of the lower end moments of all the columns of the earth story. M21 sum of the end moments of the lower ends of all the columns in the earth story. Here, so the load is acting vertical, but in this frame, the load is acting vertical. They are acting the vertical loading. As the external loading is vertical, so this horizontal force, this shear force, this is the QR, that is the summation of H is equal to QR. So this is horizontal force, so this force is equal to 0. QR is equal to 0 because there is acting the vertical loading. So the horizontal force is equal to 0. Summation of H is equal to QR is equal to 0. So all the column of the earth story are of height HR, same height. Therefore, we have from equation 4, you know from the equation 4, from this equation, if QR is equal to 0, then the summation of M12 plus summation of M21 is equal to also 0. If QR is equal to 0, then summation of M12 plus summation of M21 is equal to 0. So this is your equation 5. For the earth story, we know the general expression for end moments for member 1 for earth story. For this story, so what is the general expression for the moments for the end of the column? You can find out M12 or M21 using this formula, you know already. So MF12, this is the fixed end moment, and this is the near end rotational moment twice into M-12, plus this is far end rotational moment M-21, plus this is your translation moment or displacement moment M-12. Using this formula, you can find out the end moment M12. Similarly, you can find out M21. So this is equal to MF21 plus twice M-21 plus M-12 plus M-21. So this is your equation 6. So using this formula, you can find out what is the end moments of the member 1, vertical member 1. For a column which is vertical, if the column, this is a vertical, there is not acting any horizontal loading. So what is the fixed moment at the end? MF21 or MF12 is equal to 0 because there is no horizontal loading. So what is the fixed moment here? MF21 or MF12 is equal to 0. MF12 is equal to MF21 is equal to 0 since the loading on the frame is vertical. There is no horizontal loading. For any prismatic member, it may be noted that M-12 is equal to M-21. You know that is from the beginning, from the beam or from the slope deflection method, because M-12 is equal to M-21. This is your minus 68 delta by L square. Already we discussed here. This is M-AB is equal to M-BA0 minus 68 delta by L square. Is equal to this one. Therefore, summation of M12 plus summation of M21 is equal to 3 M-12 plus 3 M-21 plus twice summation of M double dash. But you know, summation of M12 plus summation of M21 is equal to 0 because this is 0. Here summation of M12 is equal to this one. So this is also 0. 3 M-12 plus 3 M-21 plus twice summation of M-12 is equal to 0. The summation of M-12 is equal to minus 3 by 2. The summation of M-12 plus summation of M-21. So this is your equation 8. So this is the summation of the translational moment of the vertical member. Because how many columns, how many vertical members in that story? 4. So you have to take the sum of the translation moment of that story. So equation 8 gives a relation between the rotation and translation moment. So this equation is this is the translation moment and this is the rotation moment. So this is the equation, the relation between this rotation and translation moment. So the relative displacement delta is same for all the column in the story. In a single story, so what is the displacement of the column 1, 2? The same displacement takes place in column 3, 4, and also same displacement takes place in column. So what is the relative displacement here? The same displacement for this also, and also same displacement for this takes place, and also same displacement for this column takes place in the same story, delta. So that displacement is your delta. The relative lateral displacement delta is the same for all the columns in any one story. For any column, the translation moment is equal to m dash 1, 2 is equal to 6ai delta by h square. So for this vertical member, what is the length of the member? H, height of the member. So 6ai delta by h square. So you can take delta by h is equal to phi. Here you put 6ai phi by h, and phi is equal to delta by h. Though the translation moment of a column in a story is proportional to the relative stiffness. You know what is the relative stiffness? So relative stiffness is equal to the moment of inertia of the member divided by the length of the member. So for this vertical member, so what is the relative stiffness? K is equal to moment of inertia by the height of the length of the vertical member is your h. So I by h. I by h. You know m double dash 1, 2 divided by m double dash 1, 2, summation of m double dash 1, 2 is equal to k12 by summation of k12. And m double dash 1, 2 is equal to k12 by summation of k12 into summation of m double dash 1, 2. Then substitute m double dash 1, 2 from equation 8 in equation 9. Equation 8 here. You know summation of m double dash 1, 2 here. Just put here in equation 9. So after putting, you will get m double dash 1, 2 is equal to k12 by summation of k12 into minus 3 by 2 into summation of m dash 1, 2 plus summation of m dash 2, 1. So m double dash 1, 2 is equal to, this is k12 minus 3 by 2, k12 by summation of k12 is called the displacement factor or translation factor. So you can designate this by nu 1, 2 into summation of m dash 1, 2 plus summation of m dash 2, 1. And nu 1, 2 is equal to k12 by summation of k12 into minus 3 by 2. This is minus 3 by 2 k12 by summation of k12. So nu 1, 2 is equal to displacement factor of translation. This is called the displacement factor or translation factor. This is the translation moment or displacement moment, and this factor is called the displacement factor or translation factor. So you can find out the translation moment if you know the rotational moment at both ends, and if you know the displacement factor or translation factor. If you know these two, then easily you can find out the translation moment or displacement moment. So summation of m dash 1, 2 plus summation of m dash 2, 1 is equal to sum of the rotational moment at top and bottom ends of all the columns of the story. This is at the top, sum of the rotational moment, and this is the sum of the rotational moment of the bottom of the same story. So summation of k12 is the sum of the relative stiffness of all the columns in the story. The sum of the relative stiffness of all the column in the same story. What is the relative stiffness? This one, this one, this one, and this one. So summation of k12 is equal to k12 plus k34 plus k56 plus k78. So this is equal to summation of k12. Sum of the relative stiffness of all the columns in the same story. The sum of the translation factor of all the column of a story will be equal to minus 3 by 2. So you have to check the sum of the translation factor of all the columns of a story will be equal to minus 3 by 2. Minus 3 by 2. Always you have to check the translation factor, sum of the translation factor. So that will come minus 3 by 2. So this is the formula. Rotation moment is your m dash 1, 2. You can find out the rotation moment using this formula. M dash 1, 2 is equal to u12 into m1f plus summation of m dash 2, 1 plus summation of m double dash 1, 2. and m dash 21 is equal to u21. This is the rotation factor, and m2f on the piston moment of the joint 2, and this is the near end this is the rotation moment, r end rotation moment m dash 1 plus summation of m double dash 1. This is the translation moment of the vertical member. The translation moment that you can find out for the vertical member m double dash 1. So this is the formula you have to use to find out the rotation moment. Similarly, for translation moment, this is the formula you have to use. M double dash 1 2 is equal to M double dash 2 1 is equal to nu 1 2 into summation of M dash 1 2 plus summation of M dash 2 1. Because this is the sum of the moment of the top end of the column, and this is the bottom end of the column. This is displacement or translation factor. This is your displacement factor or called translation factor, and this is your called the rotation factor. So rotation factor, this is your, what is the formula? Minus half k by summation of k, and displacement factor or translation factor, what is the formula? Minus 3 by 2 k by summation of k. This is for the vertical members. The translation factor that can be useful for the vertical members only. And the sum of the translation factor of all the column of a story will be equal to minus 3 by 2. You have to check. Then after getting the rotation moment and translation moment, then at the end you can find out what is the final moment. So the final moment is equal to m12 is equal to mf12 plus 2 m dash 12 plus m dash 21 plus m double dash 12. This is the piston moment of the end of the member. This is the near end rotation moment. This is the far end rotation moment, and this is the translation moment. Similarly, m21 is equal to mf21 plus 2 m dash 21 plus m dash 12 plus m double dash 21. Using this formula, so you can find out what is the final moment. First, you have to find out the rotation moment. Then you have to find out in first cycle. You have to take first cycle. You have to find out rotation, then translation. Again, you have to go for the second cycle, rotation, translation. So in cyclic manner, iterative process, you can find out all rotation moment and translation moment. Then at the end, when you will get the difference between the two cycles is your almost same, then you have to stop the cycle. Then you have to find out what is the final moment. This is by taking the rotation moment and translation moment. Now you are clear that is how to find out this one. So when there you are having the vertical loading. In second case, we'll discuss when there you are having the horizontal loading, acting horizontal loading. So this is the frame. So here there you are having the horizontal loading. This is the horizontal loading. For a frame subject to horizontal loading, the story shares summation of h is equal to QR. Already we have discussed summation of h is equal to QR. So this is earth story and height is your HR, and this is the horizontal member. So here you see, if all the columns of the story height is your HR, we can write the equilibrium of equation summation of m is equal to 0. Summation of m is equal to 0. So you know this is already discussed. Summation of m12 plus summation of m21 plus QR HR is equal to 0. In the story, this is the formula. So QR HR is equal to minus summation of m12 plus summation of m21. Then from equation 7 and put in equation 15. You know this is the equation 15, and you know from the equation 7. This is equation, the summation of m12 plus summation of m21 is equal to this one. So you have to put here. So mf12 and mf21 is equal to 0 from equation 7 and put in equation 15. So mf12 is equal to mf21 is equal to 0 because there is no loading between the span. So this load is your horizontal load is acting at the joint. mf12 and mf21 is 0. You then QR HR is equal to summation of 3 m dash 12 plus m dash 21 plus 2 m double dash 12. Then summation of R is for all the columns in the earth story. Summation of R is the all the column in the earth story. So how many columns is there? So for that column, this is the summation. that the QR, so you take here this side, just divide equation 16 by 3, QR HR by 3. So here minus summation of r, 3 cancel here, and here 2 by 3, m double dash 1 2. Then just to find out summation of m double dash 1 2, this one, m double dash 1 2. So summation of m double dash 1 2 is equal to, you take this side, so minus 3 by 2 QR HR by 3 plus summation of m dash 1 2 plus m dash 2 1. This is the, so after simplifying this equation, you find out m double dash 1 2. So this is the expression. This is your equation 8. Then summation of m double dash 1 2 is equal to minus 3 by 2 MRF plus summation of m dash 1 2 plus m dash 2 1. So MRF is equal to QR HR by 3. So this is your known as the story moment. MRF is equal to QR HR by 3, and this is your called the story moment. So positive when Q act right from right to left. This is, you have to consider positive when it is acting from right to left. So m double dash 1 2 is equal to K12 by summation of K12 into minus 3 by 2, then MRF plus m dash 1 2 plus m dash 2 1. Because when there is you're acting the horizontal loading, so you have to find out the story moment. So MRF is equal to QR HR by 3. So this is your story moment. So you have to add up in this moment, because in the previous case, so there was no horizontal loading, only the vertical load you are acting. So that case, the translational moment is equal to minus 3 by 2 K1 by summation of K12, and this one, the rotational moment of the top end of the column and rotational moment of the bottom end of the column. But here, what you have to do, you have to take the story moment when there you are acting the horizontal loading, MRF. So m double dash 1 2 is equal to, this is, you know, the displacement factor or translation factor, nu 1 2. So this is your nu 1 2 into MRF. So this is the story moment plus summation of m dash 1 2 plus m dash 2 1. Only you have to add this thing, the story moment. So nu 1 2 you know already. This is minus 3 by 2 K12 by summation of K12. This is your translation or displacement factor. So this is the final when there you are acting the horizontal loading. So these are the summary of the equation. So using this equation, you can find out what is the final moment. Because here you see this is the rotational moment equation. M dash 1 2 U1 2 M1F. Then summation of m dash 2 1, summation of m double dash 1 2. This is M12F. This is not M1F. So M1F plus summation of m dash 2 1 plus summation of m dash 1 2. This is the fixed end moment of the joint one, and this is the far end rotational moment, and this is the translation moment. Sum of the far end rotational moment, and this is the sum of the translation moment. Similarly, you can find out m dash 2 1 is equal to U21, the rotation factor, and M2F is the fixed end moment of the joint 2 plus the far end rotational moment 1 2 2 1 means this is your 1 2 far end, and this is the m double dash 2 1 is your equal to, so this is 2 1, this is subscript 1 2 and square, this is your subscript, not 2 1. So this is the translation moment, sum of the translation moment. So U1 2 U21 is your rotation vector. This is equal to minus of K by summation of K. Similarly, you can find out the translation moment. So translation moment is equal to m double dash 1 2 is equal to, this is the translation or displacement vector U1 2 is equal to minus 3 by 2 K1 2 by summation of K1 2. So MRF plus summation of m dash 1 2 plus summation of m dash 2 1. This is the sum of the top end rotational moment of all the column, and this is the bottom end rotational moment of all the column in the same story, and this is the story moment MRF. MRF is equal to this one QRHR by 3. Then after getting this rotational translation moment for first cycle, then you have to go for the second cycle. Again, you have to find out the rotation and translation moment, and you have to go for the third cycle. You have to find out rotation and translation moment. So in the process, you find out. So till getting the, when there is the difference between the two cycles is your very fractional part, almost equal. Then you have to stop and you can find out what is the final moment. So the final moment is equal to M12 is equal to MF12 plus twice M dash 12 plus M dash 21 plus M double dash 1. Then M21 is equal to MF21 plus twice M dash 21 plus M dash 12 plus M double dash 1. So this is the fixed end moment of the end of the member. This is the near end rotation moment, twice near end and once far end, and this is the translation moment. So this is only for the vertical member. This you have to use, considered for the vertical when you find out the moment for the vertical member of the column. So this is the formula you have to remember when you are acting the horizontal loading. This is the summary of the formula. So the sum of the rotation factor should come minus up, and sum of the translation factor should come minus 3/2. And you have to remember what is the story moment. So what is the force acting, and you have to find out what is the shear force in the story, and what is the height of the story, and accordingly you can find out what is the story moment, MRF. This is all about the analysis of frame when there is your translation of joint takes place. That is when there you are acting the vertical loading and when there you are acting the horizontal loading. All are clear?